Okay, so I wanted to run through an example of a Cramer's rule 3x3 so you could see the setup in action. Now just like you, whenever I'm doing a 3x3 Cramer's rule, all the determinants I'm going to do on the calculator, but I'm going to show the setup for the determinants on paper. That way, if I need to check your work, I've got something to check. So the first thing we do with Cramer's rule is we set up the coefficient determinant. And that starts by putting all the coefficients of the equations into a determinant. Now keep in mind again, as I've said before, all the equations need to be in standard form, so everything lines up in the same spot. So my coefficient determinant in this case would be 3, 4, -5, 2, -5, 3, and 4, 3, -2. Now I'm going to use my calculator to evaluate that in just a couple of minutes. So then I would build my variable determinants. So my x determinant, you find that by taking this coefficient determinant, but in place of the x coefficients here, you put the answers. So that x determinant would look like this: 23, -14, and 19 in the first column, but the rest of the numbers are the same as the original coefficient determinant. The y determinant would follow the same process, except instead of replacing the x coefficients in the coefficient determinant, you replace the y coefficients in that determinant. So that would look like this. And then the z determinant, which again follows the same process, except you replace the z's with that. So when I go to write this out, that would be 3, 2, 4, 4, -5, 3 in the columns, and then that answer column, 23, -14, and 19. So now I would take my calculators and evaluate each, just one calculator, and evaluate each of these determinants. So when I do these on my calculator, the coefficient determinant comes out as -63, the x determinant comes out as -126, the y determinant comes out as -189, and the z determinant comes out as 63. So now when I want to find my values for x, y, and z, the denominator of each of those numbers is the coefficient determinant. And the numerator of each of those numbers is the corresponding variable determinant. So the x determinant goes on top of x, the y determinant goes on top of y, the z determinant goes on top of z. And then you simply simplify those fractions. And that is the solution to your system. So this is the work I would expect to see on paper for 3x3s. Keep in mind, what I'm seeing is the setup of all 4 determinants. I don't need to see any of the basket weaving method to do the determinants for 3x3s. You can use your calculator to do all that work. And then I would expect to see this, and then your answer as a point.